let's look at calculating a definite integral by hand. So number 5 says use this idea of signed area to evaluate this definite integral without using a calculator. So this means we're going to graph what this looks like. Now this is an absolute value, so if you want, you could do transformations to graph it, or we could just use a t-table. So I want to do this definite integral from 0 to 3. So I'm going to do 0, 1, 2, 3, and plug them in. So 2 times 0 is negative 1. But it's absolute value, so that's going to make it a positive 1. 2 times 1 minus 1, that's 0. So we got that. Oh, hello, guys, I'm having a rough night. 2 times 1 is 2, minus 1 is 1, and then absolute value of 1 is 1. Then we plug in 2 times 2 is 4, minus 1 is 3. And then 2 times 3 is 6, minus 1 is 5. So let's graph all of these. So I have 0, 1, 1, 1, 2, 3, 3, 5. And remember, this is an absolute value, so it's going to have this V shape. So that tells us it's going to look like this. So now I want to look at this and think of this as signed area. So I need to calculate this area and then add it to this area right here. Well, if I look at these are just triangles. And I know how to calculate the area of a triangle. So let's do the area of our small triangle first. So 1/2 base times height. So 1/2, this base is 1/2 big, and the height is 1 big. So the 1/2 times 1/2 times 1 is 1/4. So that's the area of this first triangle. Now let's do the area of the big triangle. Still going to be 1/2 base times height. So 1/2, my base on this one is 2.5, and my height is 5. So 1/2 times 2.5 times 5 is 6.25. And so that is the area of this bigger triangle. And then to find the area of the whole thing, I'm going to add those together to get 6.5. And that's going to be the area, the signed area under this curve for this problem. So that's our definite integral. Okay, so let's try number 6 now. This is same kind of idea, except we don't have to solve this one. It just says set up a definite integral. So I have an integral. I'm going to have a lower limit and an upper limit. I'm going to have an equation and then a d something. So let's look at this picture. I'm going from 0 to 2. So my lower limit should be 0. My upper limit should be 2. Here's my equation. That's the graph I'm looking at. So 2x squared minus 3x plus 2. And then the variable I'm using, the language I'm speaking in, is dx. So there we go. We set up that integral. So that's really the beginning of finding definite integrals by hand. It's all about finding the area under the curve, or the area between the curve and the x-axis. And sometimes you can use shapes to do that, like this absolute value one. Sometimes it's a little harder because we've got curves, not straight lines, but we'll talk about ways to approximate that in the future. In the next video, we're going to go through a process of discovering a really important law called the fundamental theorem of calculus.